Hey guys, Algebra 2 time. Let's get right to it. Today we're working with imaginary numbers, complex numbers. Let's start off by checking out what we worked on before. We're looking at I to the 45th power. Now, for this problem, we are working with our four values of I to the first power, I to the second power, I to the third power, and I to the fourth power. Every multiple of 4 comes over here on this side. So we got 4, 8, 12, 16, 20, and then 20, 40, 60, 80, 60, 80, etc. So this is our key spot again. So multiples of 4, I could really write this as I to the 44th times I to the first power, because I know that I to the 44th is 1, I, so it's just I. Or we're just going to go around 44 times, and the 45th power is I. I'm just showing you how I could rewrite it a little bit. Now, I to the 90th power, I'm actually going to write the negative 50, because I'm going to find I to the 90th. Here's 80, here's 84, 88, 89, 90, right here. Right, 90 is right here. So that's negative 1. And that will give us positive 50. Cool. Now I'm looking at this one here. And I'm going to have the I to the 14th power and the I to the 19th power. Try it out. Now I to the 14th power, if this is 12, 13, 14. So this is negative 1. And 19th power, well, I got 16, 17, 18, 19. That would be negative I. So I got 3 times, well, I could write it all, right? It's actually going to be 3 times the negative 1 times a 5 times a negative I. And that 2 negatives make a positive. 3 times 5 is 15. And I. 15I. This last one now looks like a big number, but remember, all we care about is these last two, and 60 is a multiple of 4. So the answer to this I to the, what is it, 4,589,560 is actually just 1. Cool? Cool. Let's move on. Check it out. I got my optical illusion of the day. Remember this one? Seeing these old cars, but we're really just faked out because it's just cars sitting on a table. Big fake out. Let's move on. So I just want you guys to make sure you write this down, and when you have this and you know this, and here's our 2 big points that we need to know. Right? No one or both, they kind of mean the same thing. Alright, so write that down. So today we're going to look at real numbers and imaginary numbers, and when we put them together, we wind up with complex numbers. Complex numbers. Alright, so a real number will be like 5, and an imaginary number will be like, I don't know, negative 3i. And when we put them together, we get a complex number, 5 minus 3i. So this is what a complex number looks like. All right, this is called a complex number. All right, so let's check it out. Let's see what we can do with that. All right, so these are complex numbers. Now, this 12 plus 0i, how it's written like that is kind of weird, but this is a number that you're used to seeing as just 12. But if we want to write it as a complex number, and we'll always see this as a plus bi form. This is the complex form, a plus bi. So here's a, right? 12 is a, and b would be 0. So a plus bi, this is 12. And this is, we think of it as just an imaginary number as 4i, but we can write it complex as 0 plus 4i. And this is your basic complex number with a real component and the imaginary component. All right. So if we want to add complex numbers, it's not too bad. What we're looking at is taking the real parts and putting them together, and then we can take the complex part, or the imaginary part, and we put them together. So when we do the real part, 12 and 8 will give us 20. When we do the imaginary parts, we get 11i. These can't go together. This is not like terms. Real and imaginary, the two pieces of the complex number. Let's check this one out. We got, on this one, we got the 10. Whoops, I didn't mean to cross that off like that, but 10 minus 8 is 2. And negative 4i and 3i will give us a negative 1i. We can also write it like this. They're equivalent, they're the same, there's no difference between these two. This one here is an important one. We just have to use our basic rules of algebra that we learned. So we're going to kind of distribute our negative sign through here. So this is really a negative 4 and a positive 7i. Don't forget to distribute that negative. So 6 minus 4 is 2, and 5 and 7 is 12. 2 plus 12i is the complex answer. All right? So adding complex numbers, just like adding when we used to add with our variables x or whatever else we were doing. So it's virtually the same thing. All right? So let us try multiplying now. Multiplying is a little bit different, but the same. We've done this too. So let's start off by not crossing off that thing. Let's start off by taking this and bringing it in here. And we're going to check this out. Now, all we're doing here is just like when we're multiplying binomials, right? We're going to do the 2 times the 2, and the 2 times the 2i, and the 3i times the 2, and the 3i times the 2i. Now, I really, really recommend using the box method for this. You know, I love the box method, and I'm going to just draw my little box, and I'm going to show you something that happens here in my box method. So what happens here is I'm going to do the 2 times 2, and I'm going to get the 4 here, and I'm going to do the 2 times the 3i, and I'm going to get 6i, and I'm going to do the 2 times the 2i, and I'm going to get a 4i, and here's the interesting part. 3i, right? You got the 3i up here, and we're going to multiply it by the 2i over here. So in this bottom corner, we're going to get 6i squared. But don't forget, I squared is negative 1. So this actually becomes negative 6. Right? 6 times negative 1 is negative 6. So now we have our box. We're going to kind of combine like terms. 4 minus 6, negative 2. 4i and 6i, 10i. And there we have it. So our problem, which was this one, come on down. I'm lagging a little bit. When we multiply these two together, we get negative 2 plus 10i. Cool? Let's try another one. Here's our next problem. Our next problem is going to be our 1 minus 4i times negative 8 plus 3i. I'm going to show you how to do it. Again, I like my box method. It doesn't matter which one goes on the top. It doesn't matter which one goes down the side. We're going to create our box. 1 times negative 8 is negative 8. This one becomes positive 32i. Don't forget that when we're doing this problem that negative 4i times negative 8, two negatives turn that one into positive, right? So don't forget that. The next part of it, we're going to do the 1 times the 3 will give me, I'm sorry, this is supposed to be an I over here. 3i, and this again is negative 12i squared, and we're not forgetting that I squared is negative 1. You can see how important that is now. So this becomes negative 12 times negative 1, so negative 12 times negative 1, which will give us positive 12. And combining like terms, our like terms in here are always going to be these two on this diagonal are going to give us our first term, which is 4. And then when we look at our other diagonal, we're going to get our imaginary parts. So going across this way, the negative 8 and the 12 give us our real part, and the 32i and the 3i give us our imaginary part, and our imaginary part will give us 35i. 4 plus 35i would be our answer. Cool. We're gonna kind of skip this one for now. We'll save that one for later. I want to jump right on this one because this is one sometimes people have problems with this, but we have to remember what this is. Now, please, please, please don't make the huge error and decide that it's this. No, 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 no. This is actually 2 plus 3i times 2 plus 3i. Okay, don't make that error. Now with the 2 plus 3i, again, I'm going to do my box method on the 2 plus 3i. So I've got 2 plus 3i on the top, 2 plus 3i on the side. Of course, they're the same, so who knows which one I put on the top, which one I put on the side. I'm going to do this one rather quickly, so check it out. Right? We know that our I squared is negative 1, so I like to always cross this one out and rewrite it, right? So now it's time to combine like terms. When I combine like terms, I get negative 5 plus 6i. Final answer. All right. You could do this one on your own. I think it should come out to, let's see, 2 times 4 is 8 on that side, and the real part over here should give us a positive 18. And then we have the 12i from that, and the minus 12i from that. Check this one out. The i's cancel out, and we wind up with 26. So that one's really interesting. A complex number with imaginary components multiplied together gave us just a real number. That's pretty cool. But you could check that out with your box method, or check that out on your own. Let's move on. These are called conjugate pairs. So this is an important concept. Conjugate pairs is a huge concept in Algebra 2 that you can use in pre-calculus and calculus and beyond. Conjugate pairs is really important. If you check it out, you got 2 plus 3i, right? You got 2 plus 3i, and you get 2 minus 3i. See this pair here? 5 plus 6i and 5 minus 6i. Why are they called conjugate pairs? Just because one's plus, one's minus, right? But check out what happens when we multiply these conjugate pairs together. I'm going to get 2 plus 3i and 2 minus 3i. Again, the order is insignificant. I'm going to use my box method, draw it up. Come on, box. Come on, pen. That's right. So we got 2 times 2 is 4. And over here we're going to have 6i and minus 6i. So check that out. And then we're going to have minus 9i squared, right? So this is positive 9. But check out what happens in conjugate pairs. The 6i and the minus 6i, it cancels out all the i's. So that's what happens every time on conjugate pairs. So in this conjugate pair, it's just 9 and 4, it's 13. So this is just 13. And a conjugate pair will always give you just the real part and cancel out all the imaginary parts. So in this one here, it's a conjugate pair, right? So we get the 5 plus 6i and the 5 minus 6i. And we are looking at 25. And we got plus 30i and minus 30i. And this one here we have negative 36i squared. This turns into, it's going to be negative 36 times negative 1, which is positive 36. Again, on the conjugate pairs, the imaginary parts just cancel out every time, and all we're going to get is the real part. And on the real part, we're going to get 25 and 36, which is 61. Cool? That is us putting together complex numbers. So that's what we're working on today. So review, you can go back and review what we did. Let's move forward. Let's go back to your Google Classroom, to the virtual classroom. We're probably going to have some Delta Math today. So good luck, complex numbers. Later.